Okay, tonight we're going to take up where we left off on logarithms. What are these instructions telling you to do?
Combine them. Or get the.
Make them into one term, right? Now, it happens to be in natural log, but that's no big deal. Okay, natural log is the same thing as log base E. The rules are exactly the same. What does that and that tell you that you have? You got some stuff divided. It's in the denominator. Anytime you got a minus like that, that means it's in the denominator of the completed put back together problem. Okay, well, in this case, first thing we do is instead of pulling this power out front, we put that power back and back. In other words, it's kind of just the opposite. Don't have any powers to deal with on these two. Now then, we're going to have this x in the numerator because it's got a hidden plus in front of it. We're going to have this thing, this y to the 1/3 in the denominator. And we're going to have this z to the 1st in the denominator. Well, they're putting in this step that I would never put in. And that one too. I'd go straight to this. Okay? I would go straight to this step. I really wouldn't bother with that stuff. Because they're minuses, you know, they both got to go down here. So you don't need to do that distribution nonsense with that negative. Okay? This one was a positive. Both of those were negative. So they go in the baseline. Now, we do need to deal with this, even though it's contrary to my thou shalt nots. They'll change it to that. But I would give full credit for either answer. Yes.
Is it specifically important that we put the parentheses around all of it?
Yes. Well, not in this one because everything is multiply and divide. But if I had had x minus 1, then it absolutely would be. Okay, if you got any pluses or minus, then you gotta. If you don't, if it's only multiplications and divisions, it's not absolutely necessary. Okay. Any other questions on this one before I go on? Okay, do this one. You do this one. That's 1/4. Whoops, I just showed you the answer.
No, thank you. Thank
No,
you.
I went backwards. Okay, it's 1/4 natural log A minus natural log B plus natural log C. Okay, on this one, first thing we're going to do is we're going to take that power back. Okay, I got two pluses. And I got one minus. And if you want to put a parentheses around that, you can or don't have to.
You don't have to put the plus from the A to the 1/4 MC. You don't have to put plus to that.
You gotta unpower this or repower it, as the case may be. Okay,
Okay.
this one is a plus, so it's gotta go on top. This one is a plus, it's gotta go on top. This one is a minus, it's gotta go on bottom. Okay,
I understand that, it's just why isn't there a plus sign between A and C? So that's the way you're not adding that. What you put in the plus.
okay, look at your set of properties. Look at your set of properties, they're on 17, 18, or 19. Okay, on page 19, dead center of the page. Right now, they're in the plus minus format. We're going to the left to the single format. Notice over here in this one right here, here I had the pluses, right?
Yeah.
That you're asking about. Here, I just have the multiplications. Let's go the other way from this one. Forget that answer. Let's say that we had this. What would you do to this one? Expand this one for me. What would you have me do? There's 3 letters of that alphabet. Now, what would you put around those?
A to the 1/4.
Okay. Actually, I would go ahead. That's why it's like that. It's just opposite, just backwards of what you did going this way. It's just backwards going the other way. What was pluses became times. What was minuses became divides.
Oh, okay. Gotcha.
Okay? Now, if I were doing this from that myself, I would have done this one first. And this one probably last. But it doesn't matter. Okay? They just did it that in that order to keep it alphabetical. Okay, this one. Now, they got something special said in here. Assume everything within the logarithm represents positive real numbers. That means we don't have any negative values that would cause i's. That's what they're really telling. Okay. And they're also telling you neither one of these are 0, because then you would have an undefined. Okay, so we got the first one. And both of these, I wouldn't show that step. And I wouldn't show that step. I would go straight to this step. Let's go back and get the first one. Natural log of e over x squared square root of y equals. What I'm saying is I would go straight from that to this. Except you're thinking, where the heck did he get that 1 from? What's the rule? Anytime you have the same base of the same argument, it's equal to 1. That's one of your rules. It's on page 19. And we've also discussed it the other night. Yeah, right up here on page 19. Okay, because this is an E of E. What, Zoe? Okay, light bulb came up. So that's why this is equal to 1. Okay. Now, this one and this one, well, all we can do to that one is bring the power out front. Okay, so we're going to do this. Okay, we're going to do that. We're going to take this power, bring it out front, and this, bring this down. Okay. But you do have to remember that anytime this natural log is here, this is really log E of X.
Oh, okay.
And this is really log E of Y. Just like that was log E of E. Oops, I'm still. Now we're going to do something called the change of base formula. Okay. This is on which one of your parts? I think it's on number. Where is it?
20.
It's on page 20 at the bottom of the page. Okay, the change of base formula. They put in some disclaimers here so you don't get zeros in the denominator and that kind of stuff. Okay, or a negative here, because you can't ever have a negative for the argument. Okay. Now, you see this, either one of these can be the answer to that. Okay. Let's look what happens here. I've got log B of X. Now, what about that thing? That can be anything you want it to be. But there are two that are easier than all of the others. And that's just plain log, which is secretly log 10, okay, of X over B, or natural log, which is secretly log E of B. Okay, those are the two easiest, because it doesn't matter whether you got a TI calculator or a Casio calculator or whatever, they all have a log key, and most of them have a natural log key. Now, I'm going to tell you during the review, not right now, and I'm actually going to give you a handout, because I got to print it off. I didn't put it in your packet, and I should have. But there is a particular calculator that I recommend that you get before you go into 111. Okay, it's a Casio FX series 115 ES. You can write that down right now if you want to. Cost about $16, $17, $18. When you buy it on sale in the fall, it's cheaper than it is if you bought it today. Casio FX 115 ES, and the ES is important because they also have an MS series. The 115 ES has a key that looks like this, that no Casio has, or no TI has. And it's a key like this. You hit this button, and then you put in, let's say this were a 3 and this were a 12, just to put some numbers in there. Okay? Put the 3 in, hit the right arrow, it'll move it up to the cursor up here, put the 12 in, hit the equal button, and it'll tell you the answer to that. Now, if you don't have a calculator with that key, you got to do this and you got to do this. Then you got to evaluate this and get a number, and evaluate this and get a number, then divide those two numbers. 4 extra steps that this will do in one. So believe me, it's worth the $17 to $20. Okay. Now, you probably will have a question on your final that will ask you, they'll give you a problem, a logarithm, something like this. Okay. Something where this isn't the power of that, or that isn't the power of this, I mean. Okay. And they're going to tell you using, I'm quoting, using the change of base formula, express this as a function of, and then they'll either tell you log, or they'll tell you natural log. Or they might tell you as a function of E. Or they might use the words with respect to E or logarithms. Okay? Well, if they just say logarithms, here's what you do. Okay? You don't even have to put this A over A. You can just write log of this over log of that. If they do say with respect to E, then your answer is either this or wait a minute. I've got a 8 there and a 5 here, 8 there, 5 here, 8 there, 5 here. Okay. If they say with respect to E, then it would either need to be in this form or that form. If they say just in terms of logarithms, then it would be in this form. Okay. They have had that question on 95% of all O12 finals. Okay. Now, because we don't have the use of calculators, our use of that form, of that conversion term, is going to be very limited. We can only leave it in that as a final form, not actually find a number that you could grab. Okay, for this course. Now, guess why we can't do this problem? Right. And that one. See, here we got it. They punched in this and divided by that. using the fraction key on a calculator. Same way. If you had this problem, you could take it that far. You couldn't take it this far. Okay. You can take it that far, either in natural logs, but you can't take it that far. You notice this is the same problem as last one, same answer. The first time they used regular logs, and the second time they used natural logs. You still got the same answer. Okay. Now, solving equations. Here are the steps. I'd suggest you write those down. Unless I happen to have a handout with that on it already. I don't think I do. Okay. Okay. This is kind of an expanded version of this list. You notice the first 5 items are the same. Okay. Those are the steps for solving exponential and logarithmic equations. Okay. Now, we got to solve this one. Well, how in the world could we do that? Well, in this case, I might try changing it to exponential, see if that helps. Okay. Now, we're treating this all as one number. Like if this were 3 to the 5th. Okay. We're treating this like it's one number. Now, base stays the same. Here's the power. Here's the argument. Okay. Just like we did before. Except now we have something we can solve. -5 minus 5 to x equals negative 2. Divide by 2, divide by 2, x equals negative 1. Okay? So if we put that in there, supposedly it ought to check. Okay? Well, they're going to do the same steps I'm doing, like that. Here they're going to actually check it. If x is negative 1, 2 times negative 1 plus 5 equals questionably 1. This equals 3, right? This plus that equals 3. 3 of 3 is 1. So it checks. Unquestionable. Now, okay. And we've solved that equation. So what is one of our tools? You can change it to exponential and see if that'll help you. That's one of the tools, okay? That's step 3 on this chart. Okay? There isn't only one way to solve these problems. Okay, what about this one? Well, this is almost like the last one. Here, I change this to exponential. The base is the same. Here's the power. There's the argument. 6 squared is 36. Add 4 to both sides, get 40. Equals 5x. Divide both sides by 5, and you get x equals 8. Five times 8 is 40. Minus 4 is 36. 6 is squared to 36. So it checks.
the log features to disappear?
Because you're changing it to exponential. Which is what we did the other night while you weren't here, I guess. And basically, what I covered then is if you have log A of B equals C, then you can change this to exponential form of A to the C power equals B. Okay. Be nice, people. What?
I just didn't realize that it was about the same.
Okay. Are you okay now or good? Okay. What about this one? Solve this. This thing looks kind of nasty. Now this minus right here applies to that whole thing. Now, what we're going to do, see this directions here, move to the other side. We got logs on both sides, here and there. If you read step number 1, it says isolate the logarithms on one side. Get all of the logs on one side. Okay. Now, if this one right here weren't there, there's a different trick we can use. But for right now, because I've got a plus or minus in here, I've got to do it this way. So what I'm going to do is I'm going to add log 4 of x minus 3 to this side and that side. Those two will cancel. So it ends up over here. What was minus is now plus. The 1 is still there. Now, I've got this and I've got this. This is telling me to factor log base 4. So I've pulled the log base 4 out of here. What is this? It's just x. Plus, remember those properties we did? Plus means times, right? X minus 3. In other words, we're contracting this thing. Yeah. We're contracting this thing. So if I have a plus, that means times. Okay. Now, I can go ahead and distribute that x. So I've got this. Now then, I've got only one log. So I can switch it to exponential. When I do that, here is my base, here is my power, and here is my argument. Okay, just like I did my ABCs over here. Okay, I'm going to take that 4 over to the other side, and I now have a quadratic that I can solve. How can I solve this? Either by factoring or the quadratic formula. Okay, factoring is usually faster if it'll work. If not, then you can use the quadratic formula. It did factor into x minus 4x plus 1. So we said this equal to 0, set that equal to 0. And we get positive 4 and negative 1. So there are 2 different answers that are solutions that can be solutions on this. We need to check them and make sure that they both work. Okay. This is just showing again the 2 possible solutions. This one cannot be a solution. Right here, if you replace that x with a negative 1, you got a no-no. Because that's no solution. Okay? That's also a rule you may have missed. When you've got a statement like this, the argument can never be negative. Okay? It's no solution if that's negative. So we have to discard the -1 in this case. Now, if this had been x plus 2 right here, it might have worked. Okay? And we'd have to work it out and see. If it'd been 3, you get 0 there. You can have log of 0. It's 1. Okay. So anyway, that one is not defined. So the other one, now we'll test it. We put it in here. Here's the original equation. We put the 4 there and there, and we get this. Okay. 4 to what power is 1? 4 to the 0 power, right? So that means that this whole piece right here is equal to 0. So 1 does equal 1. So the 4 checks. A lot of things to think about, aren't there? Okay. Let them represent real numbers. And okay, what are they doing here is they're just simply making sure that I don't end up with any zeros in the denominator or any negative numbers, okay, in the logarithm. That's what those disclaimers are saying. Now, here is another rule. We've done this before, or similar to it. We've done similar to it. Remember when we were doing exponents and I had b to the third equals b to the x minus 2. And in these cases, I could remove both b's and just have 3 equals x minus 2. Take that over. X equals 5. Done. You remember doing that? Well, in a similar manner to this, that's what this is. This says that if I've got log b of x and it's equal to log b of y, then x and y have to be equal to each other, just like the 3 had to be equal to the x minus 2. Okay? So you can take it away from both sides. Okay? The both sides is the kicker. Now, why couldn't we have used a rule like this on that problem before? Because it also had the 1 minus in there. And that was 3 terms. This only works when you got a single log there and a single log there. Okay? Okay, what about this thing? I got 3 logs. As it is right now, I can't use that remove from both sides law. Okay? But you know what? There is something I can do with these two. I can contract these two. I can contract these two. Parentheses x plus 2 times parentheses x minus 1, all behind one natural log. Okay. Now I have a single natural log on both sides, which I can pull out. Okay. What did we do here? Contract. Get that upside down, didn't we? Okay. Now what are we going to do? Well, oh, they multiplied those two out. Okay. Now what they did was they removed this and this. Same thing from both sides. So it left this equation equals that. So what are we gonna do now? Get all the stuff on one side, right? Like so. Now we're gonna either factor or use the quadratic on this one. You got 5 and 3, it's minus minus, 5 and 3 make 8. So it factors into x minus 5, x minus 3. So my possible solutions are positive 5 and positive 3. Now, do they work? Okay. Here I got a 5 plus 2 is 7. 5 minus 1 is 4. 45 minus 70 is whatever it is. Okay, I've got real numbers in all of these, no negatives. That's the main thing I was looking for. Same thing with 3s. 5, 2, 27, 10. So I'm not going to run into any no solutions. Well, they're going to check them, and ultimately, yes, they are both within the domain. If you do as much check that I did just then to make sure you don't have any no solutions by having a negative x behind the log, then you're pretty much going to be safe. Okay. There are very rare exceptions to that, but for the most part, you're going to be safe.
Does that also include, like, what if behind, like, in those parentheses, what if those two numbers end up pulling negatives? But that also not including.
If you replaced one of these and you get a negative behind that, then that blows the whole thing. One negative will blow the whole thing, or that number for that answer. Okay. Now, we've had that rule before, but in all the problems that I gave you originally, the problems were we could come up with the same base. So now we're going to discuss what do you do if they aren't the same base. So you can't use that takeaway rule. Okay. Well, they'll go ahead and finish this one out. Here we have 3x minus 1, and basically we removed the base 5 on both sides and finished solving. Now, here again, we're going to have the same base. That's negative 2 to the negative, or 2 to the negative 2 power, and that's 2 to the 3x power. And that one will work. But in this case, we were still able to get the same base. And both of these are problems we've previously done, by the way. Okay. And this one, 8 and 4 are still part of the same base. I'm just going to run through that one real quick. Same idea, we get down here, remove the 2's, so we get this equals that, and you solve it. Okay. That's if you can get the same base. But what if you can't get the same base? Like this one. Well, here's the trick. If you can take away a logarithm on both sides, you can put back a logarithm on both sides. Okay, what he giveth, he taketh. Or what he taketh, he sometimes giveth. I guess, whatever. Now, and it doesn't matter whether you use log base 10 or whether you use natural log base e. Okay, it doesn't matter. What does matter is sometimes some other numbers in the problem might make it matter. Okay, and you just got to be alert to that. But anyway, we put a log on both sides of this. All right. Now, here they did the same thing with natural log. Okay. And they did it log base 2, log base 2. In other words, you can use just log hidden 10, log hidden 10, or you can use log 2, or you can use natural log, or log E, log E. It doesn't matter. Okay. Now, we pull the power out using the power rule. Okay, see this X? Now it's out front. Don't have any powers out here to deal with. Now, what are we trying to do? We're trying to solve for X, aren't we? How, can we get X from this? Okay, let me ask you this question. What if you had three X equals 5? What would you do? You would divide both sides by 3, right? And you would get X equal 5/3 in this case. Well, we've got X times that. So why not divide both sides by log 2, log 2? Okay.
Then with no calculator, that would be as far.
Well, let's see. So anyway, we got X equals log 7 over log 2. Now, in this case, yes, that would be as far as we can go with no calculators. But you got to watch out for this stuff in case you had something like a B of B, or if you had something like a 1 here.
That would be 0.
You know that'd be 0 if you had a 1 there. Okay? Or if you, worse yet, had that, that's a no-no. So that throws the whole thing undefined. But you got to watch out for those little kind of details. But fundamentally, as you asked, that's as far as you can go. If you had a calculator, that's actually what it's equal. Okay? Guess I need to erase it on. That brown can just blends in. Okay, we got this thing. Nasty looking little thing. What are we going to do? We're going to use the power rule and pull that negative 0.02x out front. Now you can do this in one step. The next you can do in one step or two. You can divide both sides by this, then divide by both sides by that, because that is times X just as much as this is. Okay? Or you can do them both at the same time, which is what they did. Okay? They took natural log 3 and negative 0.002. Here's the negative. They just brought it out front instead of leaving it down in the basement. So here you've got your 0.02, natural log 3. We're dividing both sides. Over here, they cancel out. Over here, they're there. Then if you had a calculator, you could change this to that. Question on this one. Some people don't look convinced. Anybody? Ready? Okay, what about this one? What would you do first to attack this? Yeah, I moved that 4 over by it, subtracting 4. Excuse me. Weather change is, well, no, I didn't weather change. The fact that I picked up a huge barrel of leaves this afternoon, and I'm allergic to leaf dust. Okay, well, anyway, so I take the 4 on the other side. Now what? Divide both sides by 3. Okay, now what? Put a natural log on both sides. When you reach exponentially a dead end, that's when you put log or natural log on both sides. Now, on this one, we use natural log because we had an E in it. And look what that E did. Remember, this is the same thing as log base E of E. So what's this part right here going to be after we bring that out front? This part's going to be 1. We got the 2x here equals that. Okay. Well, the 1 is a non-player. We're going to divide both sides by 2. So we get x equals natural log 7/3 all over 2. Now, this is important the way I showed this. This isn't 7/3 divided by 2. This is natural log of 7/3 divided by 2. Okay, and that does make a difference. Well, let me get rid of my scratches. They'll show you the same thing. Instead of over 2, they just showed it as 1/2. Divide by 2 times 1/2, same thing. Okay. And then they use the calculator. Well, again, this is just review, or you can change something so you have the same base and get rid of it. That's a review slide. What about this one? Take log of, see, 2 and 15 are not powers of each other. Although 2 times 25, but anyway, so when you reach this dead end exponentially, then you take either log or natural log on both sides. That's going to be a consistent pattern for your work. Okay, when you reach a dead end exponentially, you try to solve it that way first. If you reach a dead end, then you take log of both sides. Bring the power out front. Divide both sides by log of 2. Okay. And by the way, this thing could be log of 50 over, oops, I said that wrong. Nope. Can't use the properties on this because these are 2 totally separate logs. You can't have this minus that because these have their own logs. That's only if you had log of 50 over 2 as a single term. You could use that minus thing. But anyway, you got this, and all you can do at this point is leave it there since we don't use calculators. Now you find out that this is the answer to that. And 2 to that power is, it's actually 49.99 something. Okay. What about this one? We got nowhere to go. So what are we going to do? We're going to take natural log both sides. Since it's the E. Now, They just took this as equals to 1 right off the top. First, we took natural log both sides, then natural log of E or log base E of E is 1, only leaving that. Now, technically, we rolled it out front before we changed this to 1. Okay? So we got this equals that. Now we just divide both sides by negative 0.25. And we can't do this. Right here is your edge. Okay. And now that shows up. I need to resequence that where it showed up back up here. Okay, once again, here's some solving things. What do we do? First, we try to get a single logarithm on one side, and then an equivalent exponential, or we try to solve exponentially, and if that doesn't work, then we add logs to both sides. Okay, what about this one? Well, here we changed it to base power. That becomes this. Okay, that becomes that. So the answer is x equals 164. That one's pretty simple, and it does check out. Okay, what about this thing? Before we can work, notice both of these are on the same side. So what we've got to do is we've got to contract this. Okay. Wow, everything pops up at once. Okay, this or this, whichever way you want to consider it, becomes that. Okay. Now, at this point, we're going to convert this thing to exponential from right here. My base is 2, my power is 3. My argument is both of those because they're multiplied times each other. Now, that thing factors into x squared minus 1. It's a conjugate. That one's easy. Or it doesn't factor, it multiplies out. Okay, we're going to take the 1 on the other side. Okay. Now, take the square root of both sides, and this did not show that. And the plus or minus, don't forget, when anytime you take square root of both sides, that's called property of square roots, and you get plus or minus 3. Now, the question is, does negative 3 work? Well, let's look up here. If I put negative 3 in here, I'm going to get a negative 2, aren't I? And won't work. Don't need to go any farther. Don't even need to test the other side. Okay? It won't work. So we throw it out. Well, does the positive 3 work on both sides? Here we get a 4. Here we get a 3. We're good. So we go on. And they're doing the checks there. Okay. What about this thing? Right now, I can't take the log away from both sides, can I? Okay. I can contract this side. And when I contract it, okay, here's the x on top, here's the x minus 4 on bottom. I now have a natural log on both sides that I can remove. It just leaves this, just leaves that. What do? I multiply both sides by x minus 4. And I would have put a parentheses around here because the way that's shown, I would only multiply the 4 times it. So that 4, the parentheses is necessary in this case. Okay. These two cancel. Those two you multiply out. Okay. So I now have x equals that. I want to take this 3x onto this side, so I've got all my x's on the same side. Okay. Well, actually, they took the 12 over here and that over that. I don't know why in the world they would do that. I would take that over here, and I would get a negative 2x equals negative 12. Then divide by negative 2, divide by negative 2, x equals 6. That's the way I would do this from here. I don't know why we do silly stuff like that. Okay, so we got the answer 6. Does it work? Well, a 6 is okay here, a 6 is okay there, and doesn't even matter there. Okay. Once again, here's this handout that I gave. Okay. I figured that was worth you having. Okay. Even if it did take. Now, you've got this handout also. Page 21. Let's look at what they did on problem number 12 up here. I can't read that. 28 to the x equals 10 minus to the minus 3x power. Okay. This is an unsolvable exponential. Okay. That's an unsolvable exponential. So what do? We take log both sides. Pull this power out, right there. Log 10 of 10 is 1. Pull this power out front. So I now have x log 28 equals negative 3x times 1. Now, I got to get all my x's on the same side, so I'm going to take this one over here. So it's now plus 3x equals 0. I can factor out this x. If I take an x out of both of those, here's the x. Then I have log 28 plus 3. Well, 0 divided by log 28 plus 3 is still 0. We're done. Okay. What about this one? I ended up taking natural log both sides, didn't I? Okay. Why did I take natural log? Because I had an e in this thing, and I had a chance for an e of e to simplify things greatly. Okay. What about this one down here? 15 to the x equals 30. Once again, I had to take log of both sides because that's unresolvable. Pull the power out front, divide both sides by log 15, and right there is as far as you guys could go. And that equals this, which is equal to this. And then I just made this notation that this does not mean that, but I've already shown you that. I showed you that a few minutes ago. Do you see what these, and then here I've got what I did in each step in this one and what I did in each step in this one. I don't want to go over those. I want you to go over those. Okay. And it will help you with your Alex. Okay.
Do you have Alex this week?
Yes, you do. Still do Sunday night. Sorry.
No.
Not my call. What?
Last week one.
Well, let's talk about that. Just wait a minute. Let's just talk about that a minute. Now, next week, I've got stuff to cover. Okay. And by the way, all of you have this in your Blackboard course content, or course materials, rather. If you read here next week, okay, exam 5, in-person class takes exam 5 online the same as online class does. I'm giving you this one online. That allows me to have 2 days next week for a final review, or the final week. Huh? Is it timed? Yes. It's, as I'll have to go back and see. Right now, I think you've got an hour and a half, which is 15 minutes more than you would have in here. Okay. On that, basically, you've got a window from 7 p.m. on Thursday night, December 1st, until 11:59 Saturday night to take the test. It's it's like I said, I think you've got an hour and a half. You have 2 opportunities to take it. And everything I'm saying right now also applies to my online class. You've got 2 opportunities to take it. You need to go all the way through it the first time. Then it will allow you, if you choose to, you don't have to do this. If you choose to, it will allow you to rework the problems you missed. I am giving you guys a real break on that. Okay? And it'll take the highest score. Now, both the test and the retest have to be done within the time frame. No. In the hour and a half on whatever day you choose to start it. Make sure you got water with you. Make sure you went to the bathroom ahead of time, because once you start, the clock is ticking.
So you both tests together?
No. You don't have to take it the second time.
But if you choose to, you have to.
Yes,
But it's only the ones that you miss.
but it's only the ones you
You don't
missed.
have to retake the whole test.
Unless you
Right.
Right.
And that's never been your issue. Okay, so at any rate, that's the way the test is. I say in here you've got 2 hours, so apparently I put 2 hours on there instead of an hour and a half, but I need to go back and double check that. I know I gave my 111 class on their exam 5 2 hours also, and you may retake one time if time allows. Highest scores reported. No notes, no calculator, no friends, no electronic for human. Okay. Those are the circumstances. Okay. I would suggest now, I am going to change that. I am going to change that statement a little bit. And this applies to my online as well. I will allow you to use your handwritten class notes or handouts that I have given you, like tonight, during the test. You may not use anything electronic. That still stands. Okay, everyone okay with that? Now, I still haven't answered your question about can we hurry up Alex, for the last week or whatever that question was? Could you repeat it? Okay, that's a totally different question than I interpreted from you the first time. I'll talk with you on that individually. It partly depends if I've ever given you an extension before or not. Talk to me later, not now. Okay, that's not a public discussion. Okay, that's a private discussion. Now, any questions about where we're headed? Materials wise, we're going to have to do circles, distance, and midpoints. Actually, I've already covered that a little bit with you. So it's going to be kind of review on that. So the week 15 should be pretty easy for you guys. And you should be able to work your Alex well in advance since I've really covered most of it already. And then the final week is going to be pure review. Now, what I've done is, you know how I've done my citation? I found look-alike kinds of questions. I haven't seen this year's test. It'll be a brand new one because we got a brand new book. However, on a given topic, there's only so many problems you can write and come out of a problem database. Okay? So what I'm going to do is I've already got it done, but I'm going to make up a set of problems for review. And we will go over those on the board entirely. The only thing that's going to be there slide-wise is just the original problem. Okay? And in that case, what you're going to do then is we're going to go through and work all of these. And these will be problems that I anticipate being the type on the final. You understand what I'm saying? And we're going to take 2 nights doing this, maybe part of a third, since we got a Monday, Tuesday, Thursday. Okay? So then you should feel pretty well prepared for that final, I'm hoping. Okay? You'll have 5 out of the way because it's an online one, we're not going to have an after review. Okay? So that's kind of where we are headed for the long run. Okay? And hopefully that's not threatening to any of you. I mean it not to be threatening. Okay? Likewise for my online classes. So with that, let's get out of here. Okay. We're actually half a day ahead right now.